About 10:20, so keep on schedule. Our next speaker is Professor Jimmy Cain from New Mexico State University with the USGS Fish and Wildlife Research Cooperative Unit. And he has been working with us in the Jemez Mountains for several years now, and is collaborating very closely with the New Mexico Department of Game and Fish, and now with Texas Tech University, with the wildlife unit there. And so Dr. Cain is going to talk about these small and large mammal populations on the preserve in response to the fire and the future directions that we'll take in that program. So, Dr. Cain.
Thanks, Bob. I'd like to thank everybody for sticking around and not bailing out early. There's nothing worse than giving a talk to an empty room. So, like a lot of the other speakers that I mentioned, we've had decades of fire suppression, logging, and overgrazing in southwestern forests. This has had a couple different impacts. So we've had increased tree densities. This is associated with the increase in catastrophic wildfires. So we had the Las Conchas fire in 2011, which, like Bob mentioned earlier, at the time was the largest wildfire in New Mexico history. And then the following year, we had the Whitewater Baldy fire in the Gila, which is now the largest wildfire in the history of the state, or at least the largest recorded wildfire anyways. So this increased tree density typically results in a decrease in understory vegetation. And so this is associated with a decrease not only in plant species diversity, but also a reduction in forage for ungulates, so for deer and elk, as well as for bear. And there's also an overall decrease in biodiversity that's associated with these increasing tree densities. So in order to combat this, there's been numerous restoration projects that have been initiated over the past few years. A couple of big ones in our area, the Forest Initiative in Arizona, and then the one I'm going to talk about here a little bit is the Southwest Mountains Collaborative Forest Landscape Restoration Project. But both wildfires and these restoration projects designed to prevent these catastrophic wildfires can really have some severe, at least temporary impacts on habitat conditions for numerous wildlife species. So this talk is going to be broken up into two parts. The first part is just looking at the monitoring of small animal responses to the Las Conchas fire. And so this is a lot of data that Bob and his crew have collected over the last year. And then this project on the large mammal monitoring in association with the Southwest Jemez Restoration Project, we don't really have any results. We just started capturing animals last year. And so that part of the talk is going to be more of a, this is what we plan to do type of talk rather than much presenting any real results. So for the small mammal work with regard to the Las Conchas fire, there were 16 replicate sites in burned and unburned forest stands. 8 of those were in ponderosa pine forest, 4 burned, 4 unburned, and then 8 in mixed conifer, with 4 in the burned and 4 in the unburned. So here's just a couple slides. This is one of the ponderosa pine burn sites. This is one of the control sites, so the unburned site. This is one of the mixed conifer burn sites, and then the mixed conifer control sites. So you can see there are quite dramatic differences there in tree densities. And not only that, but also in coarse woody debris on forest floor, which small mammals tend to favor. And so the small mammals were sampled using 4 1-hectare trapping webs per forest type and treatment. And they were trapped for 3 days and 3 nights. So just real quickly, some of the results for deer mice. You can see there was no effective fire on deer mice abundance, right, but there was a seasonal effect. So in the burned and unburned, there was really no difference, quite a bit of overlap. But abundances were much higher in the fall than they were in the spring season. And that was for the ponderosa pine sites. This is the mixed conifer sites. And again, you can see there's no fire effect and there's no fire by season interaction, but there was a difference in season with an increase in the fall over the spring sampling periods. For golden mantle ground squirrels, these primarily occurred in the mixed conifer forest. There was no fire effect on golden mantle ground squirrels, and basically due to a lot of variability among those unburned sites during the spring. For least chipmunk, they also primarily just occurred in the mixed conifer forest. And there really weren't any detected at all in the burn sites, and there was a slight increase in the fall over the spring in terms of least chipmunk abundance. For the tree squirrels, red squirrels, and I think the data for the Ayward squirrels are similar, weren't they, Bob? They were pretty much eliminated from the burn sites. So it didn't capture any of the tree squirrels in the burn sites. But again, you do see this increase, this seasonal increase. So for the tree squirrels, there was an obvious fire effect with them being pretty much extirpated from these burn sites. So overall, this data collection is ongoing. It's going to continue for several more years. There was no fire effect on the abundance of deer mice, but deer mice abundance were higher in autumn than they were in the spring, and that was consistent for both of the forest types. Least chipmunks only occurred in the unburned mixed conifer stands, and there was really no difference in seasonal abundance. There was no fire effect on golden mantled ground squirrels, but they did only occur in the mixed conifer forest, and they were more abundant in the spring than they were in the autumn, so they're kind of the opposite pattern from deer mice. And then tree squirrels were eliminated from those burn stands. All right, so now we're going to move on to some of our objectives and our study design for monitoring the responses of large mammals to the southwest hemis. So our overall goal is just to monitor the responses of mule deer, elk, black bear, and mountain lions to these forest restoration treatments. And so here's our overall project area for the southwest hemis. Most of the project area is federally managed land, so you have Valles Caldera National Preserve, Santa Fe National Forest. There are also a small section in the Jemez Pueblo down here at the southern portion. And so we have several objectives for looking at large mammal responses. So we're going to look at habitat selection and space use. So we're going to determine what the changes are in habitat selection patterns and space use patterns in relation to these forest restoration treatments. And I'll get into a bit more detail on these in a minute. We're going to determine if and when mule deer, elk, and black bear and mountain lions start to use these treatment sites. So how long after treatment do they actually start to get utilized? We're going to look at timing between the restoration activity and use. We're going to look at seasonal use of these areas. We're also going to look at identifying seasonal migration routes for elk and mule deer. So some of this, the nice thing about this project area is it encompasses both summer range for mule deer and elk, as well as potential winter range. A lot of the elk we know go over towards Bandelier and Los Alamos in the winter, but there's potential winter range down in the southwest section of the project area, but there's really no data on if or how many elk actually winter down in that area. So hopefully we'll be able to get some information on that as well. So we're going to look at changes in forage quantity and forage quality. So we're going to assess changes in key forage species in response to these treatments. We're also going to include lag effects. If you go in and burn an area, put in prescribed fire, there's obviously going to be a lag between when you set that fire and when the vegetation responds, and then there might be a further lag between when the vegetation responds and when those herbivores actually respond to those changes in vegetation. So we're interested in what that time lag is, and it's probably going to be shorter for elk because they tend to have grass-dominated diets, and grasses are going to respond more quickly after these treatments. And we expect the response to be a bit slower for browse and mass-producing species. And so we expect more of a lag in selection patterns for mule deer and black bear. So we're going to estimate forage quality in these areas, in treated and untreated areas. And we're going to stratify these by not only treatment type, so whether it's prescribed fire or thinning, or even thinning followed by fire. We're also going to have untreated areas, but we're stratifying these by the time since treatment, the vegetation type, particular aspect, basically focusing on northern and southern aspects where you would expect more of a difference in soil moisture and hence more of a difference in vegetation, as well as fire history. And there's been numerous fires that have gone through this area in the last 15 years, And so we have fires that range from 2 years ago in the Las Conchas fire to going all the way back to about 10 years ago. And so for some of our methods, we're going to capture 32 mule deer and 32 elk and fit them with telemetry collars. So about 15 of each species are going to be fitted with GPS collars, and the rest are going to be fitted with VHF collars. So far we've got, when I did this, we had 31 elk captured. We needed to capture one more, but then one of our study animals was harvested. So we've got to put the collar back out. We're actually going to start that tomorrow. We've got 3 mule deer captured. Is it 3 or 2? 2. We've got 2 mule deer captures, not 3. But we're doing a mule deer capture starting tomorrow. So we're going to try and get some more of these collars out tomorrow. And then we're planning on capturing 7 mountain lions starting this winter. So far we've got 1 captured already. And we've got another one coming into an elk carcass, and we've since set up snares on that. So hopefully we'll have another one collared here within the next few days if we have any luck. And then we've got 10 black bears that we captured last summer. 7 of those have either GPS Iridium or GPS North Star collars on them. 3 of the bears were too small to fit with collars, so we put ear tag transmitters in them. And provided that those animals actually live long enough to get big enough to put collars on and stay in our study area, we're planning on going back and trying to capture those and fit them with collars as well. And then I've submitted several additional grants for this project, and we're trying to get more money. We want to increase the proportion of GPS collars that we have in the study area right now. So keep the 17 VHF, but bump up our sample size of GPS collars. So the mule deer and the elk collars, we collect locations at 5-hour intervals for the GPS collars. The VHF signals are going to be monitored at least twice a week, and that's primarily for mortality monitoring. And the VHF data is also going to serve as our test data after we develop our resource selection models based on our GPS collared animals. So it's going to be our holdout sample to validate our models. And then mountain lion and black bear, they collect locations at 3-hour intervals. And the one thing I should mention is these collars are stored on board, so we're not going to get that data back until the collars fall off or until they're harvested. And whereas these collars actually transmit the data every few days through either the North Star satellite system or the Iridium system. So we actually get emails with up-to-date, relatively up-to-date data on where they're at. And these VHF signals are going to be located. We're going to try to locate them more than once a week for the mortality monitoring, particularly for those bears that only have VHF transmitters. So we're going to use all this data from all of these, both GPS and VHF collared animals. The model development is going to be focused on the GPS collared data, like I mentioned, and then the validation is going to be done with those VHF locations that we obtain. And we're going to use a resource selection probability function approach for each species. And so how we're going to do this, we're basically going to have a grid over a sampling area, and the size of these sampling units are going to be unique for each species, and they're going to be based on the average movement rates of each species. And then we're going to determine the empirical utilization distribution, so it's basically like a kernel density estimate, except it's the empirical distribution based on the actual number of locations in each of those sampling units divided by the total number of locations for that particular animal. And so we're going to measure habitat variables in each of these units. And some of these variables include elevation, aspects, vegetation type. For some of the grassland sites, we're going to try and incorporate NDVI data. We're going to have estimates on woody plant cover, whether or not the site's been treated, the type of treatment, the proportion of the sampling unit that's treated, time since treatment, and then we're going to incorporate some of those forage metrics, biomass and nutritional quality, as well as distance to human disturbance. And then we're also going to develop some predation risk indices based on the location data from black bears, and hopefully we'll get enough lions to do this with lions as well. And these are going to be incorporated into the mule deer and elk resource selection models. So we're going to model these for each animal individually, and then you can average the individual level coefficients to estimate the population level coefficients. And so here's kind of just a depiction of what it might look like. So we've got all these sampling grids, and then we've got some sampling grids with more locations than others. And so we would have all of these to be classified according to all those different predictor variables that I just described. We're also going to look at changes in the abundance of key forage species in response to these treatments, as well as to just natural changes due to differences in climate between years. And so we're going to have 100 to 200 meter transects that are randomly located across our project area. And these are stratified again by some of these same predictor variables. By treatment type, we're going to monitor them over time, so they're going to be monitored repeatedly. So we'll have some that are monitored 1 year after treatment, as well as pre-treatment, and then 2, 3, 4, and up to 5 years after the treatment. Vegetation type, fire history aspect. And we're going to estimate the biomass of grasses and key browse species, as well as mass-producing species. And here's just kind of a depiction of, this is basically where our sampling locations are so far for these long-term vegetation monitoring plots. So they're pretty much distributed all across the study area, or the project area. And so we're going to, at these sites, in addition to estimating changes in biomass associated with treatment and just climatic variability, we're going to look at estimating forage quality for mule deer and elk. So we're going to collect samples of these key forage species. Right? And again, they're going to be, these sites are stratified by all these variables. And then we're going to look at nitrogen, acid detergent fiber, nutrient detergent fiber. So basically the fiber content of these species, digestibility. And then we're also going to look at secondary plant compounds, particularly for browse species. So we're going to look at tannin content and see how that changes with respect to treatments. I'm also hoping to get some additional funding to look at some fecal dietary indices over time. So we'll collect fecal samples from deer and elk and look at fecal nitrogen and fecal DAPA for mule deer. And like I mentioned, so this was kind of on the wish list, all this other stuff we're already planning on doing. And one of the things we did was we color-coded all the elk collars that we put out there, and this is going to allow us to collaborate with Game and Fish on estimating the abundance of elk in the project area. So they're going to record the data when they do their surveys, and they're going to record which elk collar, which ones they see that are collared and what the color code is on them. And then we can use the Mark Recite model and program Mark to estimate abundance of elk, rather than just having just an overall total count. We can actually estimate abundance and get some standard errors associated with that estimate. And then we're going to also determine the location of seasonal migration routes for mule deer and elk. And we're going to do this with the GPS collared animals. And we're just going to use the Brownian bridge movement model to do that. So far, we're going to have probably at least 6 graduate students on this. Right now, we've got the first student started last year, and that's Sarah Kinshu. This spring, Texas Tech is funding an additional master's student and PhD student that they're contributing to this project. So far, this year, we're going to have 3 graduate students on there. Some of our expected outcomes is we expect that this is going to provide data kind of in an adaptive management framework to guide the progress of the Jemez Mountains restoration treatment plans. We're going to determine the long-term influences of these restoration treatments on large mammals and the habitat conditions for those species. We're going to look at changes in abundance and nutritional quality for the species that the 2 ungulates and black bears that are associated with these treatment types. We're going to determine that lag period between the time of treatment and when that area actually becomes nutritionally beneficial for mule deer and elk, and when it exceeds pre-treatment levels. And so this is going to provide more data for the development of future restoration projects, but it's also going to contribute what I think is much needed data for a lot of these species-specific habitat manipulations that state game and land management agencies do. So they spend lots of money thinning and doing prescribed fire for deer and elk. Well, how long after that is it actually benefiting elk? And how long does that benefit last before those nutritional gains from that treatment actually decline back down to pre-treatment levels, and then you would have to retreat the site? Here's just some lint-cited, in case you're interested. And then I'd just like to thank the Valles Caldera National Preserve and the Santa Fe National Forest, not only for funding, but They've been a tremendous help logistically. New Mexico Department of Game and Fish has really been instrumental in providing a lot of logistical support, as well as the Hemis Pueblo, and then Texas Tech. They're contributing a couple extra graduate students, as well as some of the expertise of some of their ecologists that they have on staff there. Thanks.
We got time for a quick question while we set up the next.
Hey, so you think you have a pretty small mule deer population?
Yeah.
A lion population, maybe not that you're going to be able to.
I don't know that we're going to be able to get 7 because we're having trouble getting 32 mule deer. What I wanted was, I only wanted females for mule deer now. I had no problem getting 32 female out. We've got all these collars for mule deer. It may turn out that we have to end up just putting some on males as well if we want to get them out. And the lion densities are a lot lower than I had hoped, so we're going to try and do our best to get more lions, but I don't know that we're ever going to have 7 collared at the same time. So just because the mule deer densities are so low in our area.
Great. Thank you, Jimmy. Appreciate it. Well, thank all the speakers here. What I'd like to do in the next few minutes is give a quick summary recap of the results that have been presented so far, and then launch into the future restoration habitat programs that are going on that are actually funded and operational right now, and where we're going over the next probably 7 to 8 years in this program. So, from the results to date of the monitoring of the post-fire Las Conchas project, we know a lot about the vegetation. This has all been mapped in the post-fire environment based on the different severities. Rebecca's data has shown that in grassland systems, that the overall cover was basically not significantly different between bird and unbird sites after the first year. It came back very quickly. However, when you burrow down into the actual species dynamics, there are some plants that are accelerated in growth from fire and some that dropped back a little bit, but we didn't lose any plant species at all. Okay, they're all still there because most of their perennial parts, their meristematic stems are below ground. And then, of course, the forage values for wildlife increased after the fire. In the forest, what the data have shown so far is that we're already on that successional trajectory, going from a deep, dark second growth forest into a montane meadow habitat. So even in just 2 years, you can see the difference, and the photographs tell the story here in terms of increasing forbs and grasses and mosses and various things on the surface. Alicia has shown that the insects have come back very quickly. Some groups faster than others. The grasshoppers, of course, got hammered pretty hard, but other species were more abundant. As she pointed out, that some of the more abundant groups were probably an artifact of the pitfall trap. Pitfall traps are like miniature Bengal tiger traps. So they're sitting there as the bugs are walking around and crawl in. The burned forest floor and grasslands, of course, have very little litter. They're pretty bare, so these animals can run around a lot faster and cover more distance, which increases their probability of capture. So the message to take home on these positively affected data for these taxa are that they're still there. They're there in really good numbers. They haven't had enough time to reproduce in this first year. So this is just a distribution on the capture thing. But clearly the ones that got hammered, some of the species of ground beetles, the grasshoppers and crickets, harvestmen, and those flammable moths, those definitely went down as a result of the fire. Aaron showed us how these bird species responded to the fire. In the forest, we actually had increases in these 3 species, which has been shown in the literature pretty well, but the detail that she's getting on these particular studies has really been quite remarkable. Only 2 species went down in the forest, and these are gleaners, as she pointed out, so their habitat and their food resources are probably diminished. But it's interesting to note that these burned forests, as Aaron told us, are very birdy places. There are still a lot of birds out there, and this is probably attributable to the mosaic nature of the mixed fire severity determinations that we had. So while we're in these burned forests, only 100, 200, 300 meters away are unburned patches of forest. So these birds can frequent back and forth. They can still nest in their normal habitat and work the burned forest. The grasslands was really a surprise to me. When she showed me those data, I said, wow, you know, the grasslands from Rebecca's data looked perfectly normal. They came back immediately. And so in 2012, the first breeding season after the fire, it looked perfectly okay. But here we have highly significant drops in the number of species, and especially in chipping sparrows and American crows that were more abundant on the control sites. So what's going on there? Well, maybe we thought that maybe the grasshoppers that were burned out in 2011 might be the problem, but it looks like in 2012 that the grasshoppers are coming back big time. So we'll see how that works out. But there's also structural changes. Ground nesting birds need cover. They need big bunch grasses and whatnot. And even though they grew back nice and green, all the thatch and the litter is gone. Okay, so it may take a couple of years for that to build back up. So as she so astutely pointed out, that the successional pattern is going to keep on coming, that time is a big factor, resources are going to change in terms of habitat structure and in terms of food. And so initial responses will be mediated through time as it goes along. And then of course, the ability for us to track those food resources, the plant cover, the number of insects in these places, will be paramount in terms of understanding exactly what the root cause of these changes in the bird communities are going to do. Tree-dwelling species, whether they're birds or squirrels, do not fare well in high-severity bird forests. Okay, it's sad but true. And the ground-dwelling species that were underground at the time did survive, and the dominant ones, especially deer mice, seem to be unaffected by the fire. They have plenty of bugs to eat, as Alicia has pointed out, so they were able to hang in there pretty well. Big game, the question was, did we lose any? Well, we had 28 calves that were collared, or not collared, but ear tagged with radio transmitters before the fire, that a project that Lance Bernal and Sarah and Mark had been working on, that turned out to have survived the fire just fine with their moms. Their cows had made it just fine. So we had no known elk losses as a result of the fire on the caldera. What happened on Bandolier and the forest, we don't know. Whereas Jimmy just finished talking about, we're tracking these species through time in both the use of the habitat of burned and unburned forest, as well as future activities in terms of looking at the distribution and use of habitats with respect to forest thinning, prescribed fire, riparian restoration, and so on. This is a map of kind of the preliminary data of bears moving through the Jemez Mountains, the crosshatched areas, the burn of Las Conchas, and you can see all the bears are pretty much caught on Redondo Peak in the center here, and then they move off and go set up shop in other places here. So by analysis of these types of data, we'll be able to tell exactly how they differentially use or avoid certain of these habitats. From Matt's talk, we know that the floods created some serious issues on the water quality. Fortunately, not so much on the structure of the stream banks. They seem to hold out pretty well. But the lethal concentration of ammonia was pretty bad for the non-native trout species in these areas. And of course, the trout fisheries took a big hit in areas where the ammonia concentration was high enough to do so. And then monitoring after the fire has shown that in severely impacted areas, the trout population has not recovered. Native fish have not moved into this area just yet, but they're starting to. They're just getting into those areas. And in places where the trout were eliminated, but the native fish are still there, those populations are starting to really come up fast. So you take away the top-down predator control, and the native non-predaceous fish do very well. And then Jerry Jacoby talked about the aquatic macroinvertebrates in the streams, and while he found that there were some moderate reductions down to slightly impaired conditions here due to the reduced number of species, number of individuals, basically the aquatic invertebrates are pretty resilient. They survive in pretty good shape in a lot of places and will provide the food base for future fish populations as they come back, depending, of course, on what the sediments do in the future. So, Now that we know that we've had the Las Conchas fire and that we are understanding some of the responses that have occurred here, how can we manipulate the habitat, the wildlife habitat, the fisheries habitat, etc., to try to avoid the next Las Conchas? Because the western 2/3 of the Jemez Mountains have not burned severely in a long, long time. So we've got to get in there and do something about it. Harking back to yesterday's plenary talk by R.J. Kirkpatrick from the New Mexico Department of Game and Fish. He's a very strong proponent of get out there and do stuff. So that's what we're doing right now in collaboration with the Santa Fe National Forest and a whole suite of different groups from northern New Mexico. And here's just a list here. I'm not going to go through this, but you can find your favorite organization up here. But all of these groups and the people involved have been contributing a lot of effort in terms of planning, and now it's on the ground actual activities to get things done. It's a $35 million grant that goes for 10 years. We're in the third year of it right now. And the idea is to restore forests, reduce the threat of uncharacteristic, read that as catastrophic wildfire, and to restore a number of the habitats and the species that belong in these forests so that natural fire cycles can come back in and take over with a much more cost-effective management approach. So, in Ponderosa Pine Forest, this is kind of our idyllic, desired condition. Very park-like conditions, 40 to 60 trees per acre, but unfortunately this is what we're dealing with right now given the history of logging and the general suppression of fire in these areas. So these densities range from 800 to 2,000 stems per acre. In order to get in here, we have contracts now to have companies, private sector companies, come in and start thinning these trees. Many of you know what a barco is. It gets in here and starts chewing up trees. There are also equipment that, for the larger ones that they can actually use, they can take it down at the stump, cut it up, deck it, have it all ready to go, and truck it out. Right now we're supplying logs off the caldera to Walatoa Timber Industries, a small business that was started up as a part of the CFRP program in the state of New Mexico. So as much of the wood as we can get off-site is being used right now in industry. The rest of it gets mulched or masticated on the ground. This, of course, leaves a lot of litter, and so we've got to come in there and burn that. So after it's been on the ground, dries out for a couple of years, we do prescribed fires. We've started those this last year on the caldera, and prescribed fires have been going on the forest here for a couple of years now. This was one of our prescribed fires a couple of years ago in the Valle Toledo. This is in conjunction with a lot of federal agencies, Park Service, Forest Service, various pueblos come up to help us with this. So we're laying out black lines, and then you would bring in the helicopters with the exploding ping pong balls of ethylene glycol, potassium permanganate. We did these fires going on a large scale, so we can actually burn thousands of acres at a time in a relatively short period. Because we're going to have to. As we get up, some of these fire return intervals in grasslands are 4 to 6 years. Fire return intervals in Ponderosa Pine are 10 to 12 years. Fire return intervals in mixed conifer is about 20 years. So if you're burning Ponderosa Pine Forest, you've got to burn 10% of your forest every year to keep on that cycle of a natural fire cycle every 10 years. We burn in the understory to try to reduce the fuels and the ladder fuels in these forests. So we've been running on those. We did a nice 7,000 acre burn with the Forest Service. They conducted this fire on San Juan Mesa last fall, and very good success rates. These are repeat photos that Rebecca and I have taken before and after this fire. So you can see high densities of young ponderosa pines. They're the makings of a dog hair thicket. That is, the trees are as thick as the hair on the back of a dog. So this is clearly how you get started on these, and this is after the fire comes through. Here's New Mexico locust and Gamble oak comes through afterwards. So a very effective way to go. The other ability of restoring forests to get to the point where they're thinner and the fuel loads are reduced is that you can improve your watershed health and hydrology. We've had our colleagues at the University of Arizona study this for a number of years now on the preserve, looking at the throughfall of snow in the winter. It turns out that if you you have high-density forests, snow gets hung up in the branches and it sublimates, and as it evaporates back in the atmosphere, blows off to Oklahoma. We'd rather keep our water here, okay? If you clear cut it, the snow gets on the ground, but again, wind and sun sublimate the snow water equivalent and it's gone. If you keep some trees around, thin the forest down to, oddly enough, about 40 to 60 trees per acre, the snow gets to the ground and is sheltered. The trees break up that laminar flow to keep the air boundary in there, and they shade the snow. So sublimation is reduced by about half in a situation like this. And this illustrates it. I took this photo on the preserve in April, and you can see that in the interspaces where snow got to the ground but are still partially shaded, the snow is still there. Whereas in the bright, open, sunny spots, it's gone, and underneath the trees, it's gone, because there wasn't very much to begin with. So when we look at the hydrology of this, it turns out that most of the runoff is in springtime. If you look at the overall hydrology, the majority of runoff occurs during the winter-spring period. Okay, so that's where most of the water comes off the area. Well, harkening back to David Brookshire's talk yesterday about ecosystem services and dollar values, we find here that if you run the numbers here, and I won't go through all the details, but given all the production that we have, if we increase runoff in the spring alone, which is most of our water production, we have about $2.2 million in new water produced on the preserve each year. So this is a big deal. We don't own that water, unfortunately, but it basically is a contribution to society downstream. Helping with riparian and restoration, we have groups like the Wild Earth Guardian that has come in and worked to put woody plants back into the environment again and establishing shades so that we can cool down the stream temperatures and stabilize the banks. Grazing restoration has always been a problem in public lands, but we reduced our stocking rate when we first acquired the preserve by 95%. So the recovery has been pretty good in grasslands. One of the legacies of this, however, of course, is fencing. Wildlife gets tangled up in fencing. Sheep fence, like here, is also a barrier to young cows going across, young elk calves trying to get across fences, and coyotes can knock them off at the fence line there. Animals get stuck in these fences, and if there's nobody there to rescue them, they, of course, meet their maker at that time. So we get groups out like Wild Earth Guardians and Great Old Broads of the Rio Grande and Caldera Action, and folks come out here and pull these out. This is interesting. While we're doing this, you can see a herd of elk right here. 4 calves on this side of the fence, a couple of moms, but the rest of the herd is over here, and this caused a huge commotion because we have people here and we have people up on this side working down towards the valley. But one day worth of work and the fence is gone. So this is action on the ground, get stuff done, make it good for habitat. If you're going to go ahead and put fences up, do wildlife-friendly fence. That's what we're doing on the preserve now. Smooth wire top and bottom, drop the top stand, raise the bottom strand. So animals can go over or under. And finally, of course, restoration helps with some of these salamanders, the Haines Mountain salamander, improving their habitat. Really quickly, I'm going to run through a bunch of fast slides here just to give you an impression that while habitat restoration is great for people, recreation values improve, everybody has a grand old time out there, and it's really good, but people are part of the problem in terms of restoration and maintaining good habitat. Because it turns out that some folks, especially young males driven by high levels of testosterone and alcohol, seem to drive into mud at every chance they get. And so that obviously has issues for riparian zones and wetlands if this type of behavior keeps on. Some folks are really not very bright about this sort of thing. In addition, we've got law enforcement issues of having people cleaning up their trash. This attracts bears and other animals into these areas. Of course, we know that a fed bear is a dead bear. You're supposed to leave courtesy, firewood behind. This guy left his grill. That was very nice of him and whatnot. But people leave tents, all kinds of stuff at these campgrounds. This is all from the Haines district along Supplier Creek. And in this case, you know, they just leave all this crap left behind. So it's really obnoxious, and somebody's got to go in there to take care of it. And speaking of crap, There are other issues that campers come out and leave behind, including these sorts of things. Just a real quick quiz for the students in the room. What is the average distance between one of these porta potties and the center of the campfire ring? Now, most of us here are probably a little shy about doing this sort of thing in the open. What do you think the average distance was?
15 feet.
Close. 10. 10 feet from the campfire ring. So you and your buddies and your family, oh, I think I'm going to leave myself right here. In any case. And then, of course, finally, we've got human behavior on where they build their houses. And obviously, putting in defensible space in the wildland urban interface. Some are defensible, some like this are clearly not. Okay, so we've got issues with people kind of with their personal preferences on how they landscape their house. So fire in the system is a natural thing. It's been here for many years. Every time you see an aspen clump, the odds are that's an old fire scar, much like this one's going to be in 50 or 100 years from now. We want to try to work to avoid the conditions that will create a Las Conchas fire like this. That is a large area stand replacement fire. But the important thing, and this is where RJ and I kind of differ a little bit, is I think we have to have monitoring. You have to have the science in there to know if your projects are working the way you think they are supposed to. And in our particular case, we only spent 8.9% of the budget on monitoring. And you've seen the presentation today and how comprehensive that can be if properly organized. So the idea here is to do a lot of action on the ground, but to keep track of it as well. And with that, I think we can have generations to come of idyllic conditions for recreation and wildlife and fish on the preserve and in public lands. So thank you very much. These are the organizations that contributed to the talks today. And I thank you for your attendance. And hope you've all learned something today. I know I have for sure. Thanks again. I know I'm kind of over by a few minutes, but I can hang around. This is the last thing for our session, so I can take questions as long as you want. So.
Yeah, I just had a question about nutrient losses in the soils, because a lot of erosion has occurred, a lot of soil has collapsed because of water. But then also you're removing the trees, and the trees and the nutrients are then gone to that system of the slash. So what are you doing about that?
That's right. The trees, it turns out, don't have a lot of nutrients in them. It's mostly tied up with needles and leaves and the roots, as it turns out, that start to decompose and cycle back in there. So taking the wood, basically the cellulose off-site is not that critical. It's actually, if we can use that wood in furniture and what they build are vigas and latias and dimensional lumber, that on average lasts 100 years, so it takes it out of the carbon cycle, if you will, for a century. Now, it doesn't amount to very much, but it's great to get it off-site so we don't have to burn it and deal with it while it's on site.
But what about the erosion from high-intensity burn areas? It's a lot of soil loss.
That's a lot of soil loss, absolutely. And, we'd rather not see that. But again, nature's been doing this in the Jemez Mountains, which are volcanoes anyway, for millions of years. And the Jemez Mountains will erupt again. It's not an extinct volcano, it's a dormant volcano. And so it'll come up and blow up again, and hopefully we'll be done with a nuclear lab by that time on the flanks of that volcano. But with any luck at all. But yeah, so the system can deal with that. Those nutrients, of course, have gone downstream. One of the little factors, I can't remember if I mentioned or not, is that the soil pulse that came off of the Cerro Grande and Pajarito Mountain into the East Fork has plugged up the central part of the Valle Grande, and now we have basically a fen, a marsh out there where there used to be an incised channel. And so there are some of our soil scientists that believe that would have been the original condition of the open valleys, that incised streams are a result of 19th and 20th century grazing activities. And so this may be nature's way of repairing itself by dumping sediments down in there in large quantities and then restructuring the stream upstream from the plugged areas. So hypothetical anyway.
How's the CFLRP doing with, you said to keep up with that Conchas fire interval will be approximately 10% per year
Right.
treatment. So how is the CFL, how is it doing keeping up with that?
Well, we just got started. We're 3 years into it. For most of our ponderosa pine forest, which had been logged before, it's all second growth. So the first thing we need to do is get in and thin it first, and then it goes on the burn cycle. So at this point on the caldera, we've done less than 3,000 acres of ponderosa pine right now in the last several years. And the area that we started thinning back in 2004, we burned this fall. So it's on the cycle. So as we get more and more sites ready to go, they join the cycle, and then we'll get them.
So is most of the money with CFLRP associated with just doing the mechanical thing?
A lot of
And
it
then
is.
you can introduce the fire cycle later, a little later date.
That's correct. That's correct. So there's a series of steps to get it to that point. And then, with any luck at all, we can let natural fires just continue to burn. So we just get out there and watch them, keep an eye on them. And if they got wildly out of prescription levels, then we want to go in and have the firefighters go in and stop them. So, yeah, Mark.
Bob, there was a recent decision, as you know, by the board to double or triple the number of recreationists on the Valles Caldera.
Right.
And increase roads, improve roads and all that. Do you have a sense of how you're going to be able to integrate fuels treatments and prescribed fire with all the increased recreational visitation?
Yeah, I don't think that should be too much of a problem. Most of the burning that we would do would be either early spring before the real early summer winds come up, or in the fall, which kind of brackets the portions of the activity periods of